Chapter 4 is on chemical reactions. I invited two friends for lunch today. We are going to have a grilled cheese sandwich luncheon. And since it's me and two friends, I need to cook 3 sandwiches. In my refrigerator, I have plenty of cheese, but not enough bread. I need to go to the store and I need to know how much bread do I need to buy. Now, my production of my grilled cheese sandwich is based on this chemical reaction I've written here. So 2 BRs represents my 2 pieces of bread. 1 CH is my 1 piece of cheese to produce 1 sandwich, which is represented with CHBr2. I can use this information to show me the relationship between the bread and the sandwich and use that to help determine how many pieces of bread I need to make the sandwich. And I'm sure off the top of your head, you know if I'm making 3 sandwiches and each sandwich has 2 pieces of bread, I'm going to need 6 pieces of bread. But I just want to show you how we're going to set it up that we'll be using in doing chemical reactions to solve from one quantity to a different quantity of either reactant or product. So whenever we're solving word problems, we start with what we're given. So we're given 3 sandwiches, which is 3 CHBr2s. I am trying to find how much bread. My bread is BR. Now I can use my balanced equation to show me the relationship of how I can convert from CHBr2 to BR. And what I'm going to use are the coefficients between my different quantities of bread to CHBr2. So my equation tells me that 2 pieces of bread will produce 1 sandwich. So that's basically an equality. 2 breads equals 1 sandwich. If we have an equality, we can create a conversion factor by putting that in a fraction format. So we can say either 2 pieces of bread divided by 1 sandwich, CHBr2, or 1 CHBr2, which is my sandwich, over 2 pieces of bread, or 2 BRs. So let's go ahead and solve this problem. So we start with our given, which is 3 CHBr2, and then I'm going to multiply by one of my conversion factors. I want to pick the one where the units are going to cancel. So the one on the left has CHBr2 at the bottom. That's the one we want to pick. So I write 1 CHBr2 at the bottom, which is equivalent to 2 pieces of bread at the top. Now my sandwiches cancel out, and then I just multiply 2 times 3. I get 6 pieces of bread, which again, I knew you could do this off the top of your head, but this is showing you how you could solve the problem. The coefficients in a balanced equation tell us the number of molecules of reactants that will produce the number of molecules of products. In this example, we have 2 molecules of hydrogen gas reacting with 1 molecule of oxygen gas, producing 2 molecules of water. How many molecules of water are produced from 1 molecule of oxygen? Our coefficients in our balanced equation determine that. So 1 molecule of oxygen produces 2 molecules of water. And we're assuming we have plenty of hydrogen. This shows us a molecule of oxygen and 2 molecules of water. How many molecules of water are produced from 2 molecules of oxygen? So here are my 2 molecules of oxygen. So I'm basically doubling the quantity I have, and we know that 1 molecule of oxygen produces 2 molecules of water, so we should produce double the quantity of water, and here's my 4 molecules of water. We can write this out to show how we would solve our problem by starting with what we were given, which is 2 molecules of oxygen. We can use the coefficients that are related in the balanced equation, which tell us 1 molecule of oxygen produces 2 molecules of water, which is an equality, and create our conversion factor. So 1 molecule of oxygen would go at the bottom of our fraction, and 2 molecules of water would go at the top. And again, we set it up in this format so molecules of oxygen are canceled, and then we end up with 4 molecules of water. How many molecules of water are produced from 6.02 times 10 to the 23rd molecules of oxygen? Now I can't draw that many molecules because that's way too many, but we can use our relationship between the molecules of oxygen and water in our balanced equation to calculate this. So we are given 6.02 times 10 to the 23rd molecules of oxygen. And we can use the relationship between water and oxygen and say 2 molecules of water are produced from 1 molecule of oxygen. So again, it's going to be double the quantity that we're given. We can cancel the molecules of oxygen, and then we just have 2 times 6.02 times 10 to the 23rd, which would be 12.04 times 10 to the 23rd. How many moles of water are produced from 1 mole of oxygen? Now we know in the previous question we had 6.02 times 10 to the 23rd molecules. That's the same as 1 mole of oxygen. So we can also put this in terms of moles. So our coefficients can be telling us the quantity of molecules or moles. So we could also say 1 mole of oxygen is equivalent to 2 moles of water. So we could set up our problem here to say 1 mole of oxygen, and then we have the relationship between moles of water and moles of oxygen. 2 moles of water divided by 1 mole of oxygen. We would get 2 moles of water. Our coefficients in our balanced equation gives us our mole-to-mole relationship between our reactants and our products. In other words, the coefficients in a balanced reaction tell us how many molecules or moles of something will produce how many molecules or moles of something else. So we can relate one compound to another compound using the mole or molecule relationship. So in this chemical reaction, we have 3 molecules of hydrogen reacting with 1 molecule of nitrogen, producing 2 molecules of NH3 or ammonia gas. Or we could say 3 moles of hydrogen reacts with 1 mole of nitrogen, producing 2 moles of ammonia gas. So we can ask how many molecules of NH3 are produced from 1 molecule of N2. We can use our balanced equation to solve for that. So 1 molecule of N2, based on our balanced equation, we said 2 molecules of NH3 are produced from 1 molecule of N2, which gives us 2 molecules of NH3. How many moles of NH3 are produced from 1 mole of N2? We can use the same format. We have 1.0 moles N2 times 2 moles NH3 divided by 1 mole of N2. So moles of N2 cancel, and we end up with 2.0 moles NH3. The coefficients in a balanced equation can be used as a conversion factor to convert from moles of what you know, which is the information that's given, to moles of what you don't know, which is what you're trying to find. You can use your coefficients to convert. So that's basically saying the moles of one substance, you can convert to moles of a different substance using the relationship between those coefficients in a balanced equation. How many moles of oxygen will be produced by the decomposition of 5.8 moles of water? Let's start with the plan. We are given moles of water. We are trying to find, or what we don't know, is moles of oxygen. In order to go from moles of one substance to a different substance, we need to use the coefficients from a balanced equation. So we need to balance the equation that is given to us. So we have in water 2 hydrogens and 1 oxygen in our reactants. And in our product, we have 2 hydrogens, which is balanced, but we have 2 oxygens in our other product. So we need to put a coefficient in front of water of 2. Now we have a total of 4 hydrogens and 2 oxygens. So in front of the hydrogen in my product, I need to add a 2. Now I have 4 hydrogens, and that balances the 2 oxygen atoms in a molecule of oxygen. So we have our balanced equation. Now we can solve our problem. So we start with our given, which is 5.8 moles of water. I'm going to create the conversion factor by looking at my balanced equation for what's given and what I'm trying to find. So what I'm going to look at is I have 2 moles of water producing 2 moles of hydrogen and 1 mole of oxygen. The amount of hydrogen in this reaction we're not concerned about. So in all of these types of problems, you're only going to be looking at one compound as a given and another compound as the one you're trying to find. So I circled water and I circled oxygen because that's the relationship we're looking for of the coefficients in my balanced equation. So that's telling me 2 moles of water is equal to 1 mole of oxygen. And again, that equality I create a conversion factor for. I want moles of water at the bottom. So I have 2 moles of H2O. And at the top I have 1 mole of oxygen. 2 moles of water. I can cancel the moles of water. So 5.8 divided by 2 gives me 2.9 moles of oxygen. How many moles of NH3 are produced from 2.5 moles of N2? Let's start with our plan. What we are given is 2.5 moles of N2. What we're trying to find, or what we don't know, is moles NH3. So how do we get from A to B? To go from moles of one type of compound to moles of a different compound, we use those coefficients in the balanced equation. So we are given an equation here. We need to balance that. So if we look in our reactants, we have 2 hydrogens, and in our product, we have 3 hydrogens. If I put a 3 in front of H2, I have a total of 6 hydrogens. And if I look in my product, I have 1 nitrogen and 3 hydrogens, so I put a coefficient of 2. That gives me 2 nitrogens and 6 hydrogens. And that also balances my nitrogen, so I don't need a coefficient in front of the nitrogen. So my balanced equation is 3 moles of hydrogen reacts with 1 mole of nitrogen, producing 2 moles of NH3. And in the problem, we're given just nitrogen, and we're trying to find NH3. So we're looking at nitrogen's relationship to NH3. So that's 1 mole of N2 is equivalent to 2 moles of NH3. That's the ratio between these 2 compounds. And based on that equality, I can create the conversion factors. I can say 1 mole of N2 divided by 2 moles of NH3, or 2 moles NH3 at the top of my fraction divided by 1 mole of N2. Now I can go ahead and set up my problem. 2.5 moles nitrogen times, I want to pick the conversion factor that will cancel the units of nitrogen. So we have 2 moles NH3 at the top divided by 1 mole of N2. Our moles of N2 cancel, so it's just 2.5 times 2, that's 5. We want to watch our significant figures. Our problem 2.5, we were given 2. What we're given in the problem determines the number of significant figures in our answers, so we need to add a 0 to have 2 sig figs in my answer. So it's 5.0 moles NH3. MOL is an abbreviation for mole. How many moles of water are produced from 10 moles of hydrogen? So we'll start by recording what's given, which is 10 moles of hydrogen. And what we're trying to find is moles of water, our question. And how we go from moles of one compound to moles of a different compound is using the coefficients in our balanced equation. So we are given an equation and we need to balance it. So when we look at this equation, we have hydrogen plus nitrogen monoxide forming NH3 or ammonia and water. The hydrogens in the reactants, there's 2. The hydrogens in the products, there are 3 in NH3 and 2 in water, there's 5. So we have an odd number here. Our hydrogens are not balanced. Our nitrogens in the reactants, there's 1. In the products, there's 1. 1 oxygen in the reactants, 1 oxygen in the products, so it's balanced. So one thing you might think, well, to balance 5, that's an odd number. I could put a 2.5 in front of the hydrogen and I'd have 5 and I'd be done. But when you're balancing equations, you always have to have whole numbers. We can't have half a molecule. So this is something you can do that it's balanced, but it's partway. So what you could do is multiply by 2, and your coefficient in the front will be 5. But if we do that, we have to multiply everything in the reaction by 2. So this is kind of another trick to balancing equations. If you can't figure out what coefficients to use, you can try using a half a molecule, like 2.5, and then multiply everything in your reaction by 2. So then my coefficients would be 2 times 2.5 gives me 5, and then a 2 times 1, and a 2 times 1, and a 2 times 1. So I'm going to go ahead and erase what I've done here and just write my 5 in my spot. Now we can check to see if it's balanced. So 5 times 2 hydrogens gives me 10 hydrogens. 2 times NO gives me 2 N's and 2 O's. 2 times NH3 is 2 nitrogens. 2 times 3 hydrogens is 6 hydrogens. 2 waters is 2 times 2 for the hydrogens. We have 4 hydrogens. And 2 times the oxygen gives me 2 oxygens. So now we can see on the left we have 10 hydrogens. On the right we have 6 hydrogens plus 4 hydrogens is equal to 10 hydrogens. We have 2 nitrogens on the left, 2 on the right, 2 oxygens and 2 oxygens. So we have a balanced equation. So we can go ahead and solve our problem now. So 10 moles of hydrogen. And now we're looking at our problem. We're looking at the relationship between the moles of hydrogen and the moles of water. So we don't need to worry about nitrogen monoxide, and NH3. So we're going to look at our coefficients here, and we're looking at 5 moles of H2 is equivalent to 2 moles of H2O. So we can set up a conversion factor using that. So we'll put 5 moles of H2O at the bottom of our fraction and 2 moles of water at the top. So our moles of hydrogen will cancel and we'll get moles of water, which is what we're after. So it's 10 times 2 gives me 20, divided by 5 is 4. And then for significant figures, we have 3 given in 10.0, so we're going to need to add 2 zeros, so we have 3 sig figs. So my final answer is 4.00 moles of water. How many moles of CO2 are produced from 2.5 moles of C6H12O6, which is glucose? In the reaction, we have solid glucose plus oxygen gas reacting to form carbon dioxide and water. So we need to create our plan, which is we are given 2.5 moles C6H12O6, and we are trying to find moles of CO2. And in order to go from moles of one type of compound to moles of another compound, we need to use our coefficients in our balanced equation. So we need to balance the reaction that is given to us. And we can see in our reactant, we have C6H12O6, there's 6 carbons. In our products in CO2, there's 1 carbon. So let's start by adding a 6 in the front here. The other thing you should look at in this compound is which element should you start with? Should you start with carbon, hydrogen, or oxygens? Carbon is okay to start with because it appears only once in the reactant and once in the product. If you look at oxygen, it appears in 2 of our reactants and 2 of our products, so you definitely would not want to start with oxygen. You could also start with hydrogen because hydrogen starts in 1 of the reactants and it also shows up in 1 of the products. So let's balance our hydrogen next. So we have 12 hydrogens in the reactant and we have 2 in the product, so we can add a coefficient of 6 in front of water. And now it looks like our carbon and hydrogen should be balanced. So let's total up what we have right here. We have 6 carbons in glucose, 12 hydrogens, and 6 oxygens. We're going to save oxygen for the last to balance. And in our products, we have 6 carbons in CO2, and 6 times 2 gives me 12 oxygens and 6 water molecules. I have 6 times 2 or 12 hydrogens, and 6 times 1 oxygen gives me 6 oxygens. So what we're trying to balance is the oxygen. The amount of oxygens we have in the reactants total is 12 plus 6 gives me 18 oxygens. Now in the reactants, we already have 6. So we have to figure out for oxygen, which is diatomic, there's 2 oxygen atoms in 1 molecule, what number is going to take to balance it. So we can say 18 minus 6 gives me 12. That's how many oxygens it's going to take to balance it. What number, 2 times whatever number, is going to equal 12? So that's 6 that we can use as our coefficient. So now we can check. 6 times 2 oxygens is 12 oxygens if everything is balanced. The 6 carbons are balanced. We have 12 hydrogens, which is balanced. And now we have 6 plus 12 oxygens in the reactant, which equals 18 oxygens. So that balances 18 oxygens in the products. So now we have our balanced equation. We can solve our problem. 2.5 moles C6H12O6 times, we're going to look in our equation to find a relationship between our moles of CO2, which is 6, and our moles of glucose, which is 1. So 1 mole of C6H12O6 goes at the bottom, and that's equivalent to 6 moles of CO2. Moles of C6H12O6 cancels, so we have 2.5 times 6 gives me 13 moles of CO2. This is a review of the 3 types of conversions we've discussed in Chapter 4. The first is if you are given moles of a substance and you are asked to convert to atoms or molecules of that substance, you need to know how to convert, and you would use Avogadro's number. If you are given moles of a substance and you are trying to find grams, you need to know how to convert that. And you can remember grams to moles to grams, use molar mass. Or if you are given moles of one compound, let's call that compound A, and asked to find moles of compound B, a different compound, you would use the coefficients in your balanced equation.